How's it going, everyone? Sorry about the 4 videos yesterday. That's not the ideal way that we would have liked to have taught this content. However, we probably will not do something like that again. We may have a Khan Academy video or two that we end up showing, but you guys have seen like 5 different videos now, and now you've got a couple more coming your way today, and I'm sure you're getting pretty tired of it. That's understandable. I wanted to take about 5 minutes here, maybe 10, depends on how much I jabber. Just kind of going over after you got done with all 4 videos and with the video that I made a couple of days ago or on Friday. Um, Go over some of the content and just make sure that you guys just kind of see a snapshot of the big ideas. First thing I wanted to do is just talk about the graphs. I'm aware, those of you, and I mentioned this before, that are in pre-calc right now, you guys know the difference between a sine, a cosine, negative sine, and negative cosine graph. But even more than that, I want to make sure that we understand this order in particular, and then going back to sine. The reason this is important, when you guys do take calculus, you're going to learn about derivatives, and the first derivative of position versus time equation is velocity. So what happens is the derivative of a sine graph is a cosine graph. So if we end up with a position time graph that is a sine graph, you know the velocity graph is a cosine graph. Then you know the acceleration graph is a negative sine graph. If the position versus time graph is a negative sine graph, now you know the velocity is going to be a negative cosine, and you know the acceleration graph is a sine. So just knowing these in this order, and then to begin at the beginning, like I said, that's not a great way to teach this, but it's just something to kind of memorize and have in your memory bank. Okay, so one cycle, we go through one over and back, and we're basically looking for any 2 consecutive points of one of these wave diagrams is when it restores itself. The amplitude and negative amplitude are the maximum stretch and compression distance of the spring. So all of this is going to begin with 0 here in the middle. Now, one thing I want to make sure that you guys understand and be aware of, this is based off of us establishing 0 here. Those of you taking the AP exam, you need to be aware that sometimes the AP will just put a random position as a relaxed state. So this entire graph may be above or below the 0 point, in which case you still want to draw a line straight through the middle of it and split up the amplitude as positive and negative, okay? I'll see if I can dig up one of the questions that has been on the AP exam in the past and give it to you guys at some point this week. All right. When we're going through a cycle, remember, even though it's going in one dimension, we can treat it as circular motion. Since we can do this, even though it's accelerating right and left or it's accelerating up and down, if we put the X and Y graphs together, we end up with just some object that's moving at a constant angular speed. So one cycle means that this object goes through 2 pi radians. So omega is simply 2 pi over t, or don't forget the inverse of period is frequency, so we can write omega as 2 pi f. You guys will see as you get progressing into the problem sets, on some of the questions that involve solving for omega, I may use the period, and in others I may use the frequency. I really have no rhyme or reason for that. Most of the time it's simply based on is the number for the period like a 0.33 number or a 0.667 number, and then the frequency is a whole, or is absolute through 2 or 3 sig figs. I'll probably use the frequency. These problems, what you're going to find, even if you round numbers, you're going to find that your position may deviate from the actual position that the object is in. Obviously, Mr. McDonald and I will not be taking points off for that, but you just need to be aware. Try to always use the more accurate value if at all possible. Okay, writing the position as a function of time graph. Now, I'm using sine, but remember your positions graph can be any of these 4. So you need to be aware that you might have to end up changing the trig function. So remember, x equals a sine of theta, and theta is omega times time. Remember, this is 2 pi. So this is omega times time here, and we can sub in the 2 pi over t or the 2 pi f t in for that expression. Those taking the AP exam, this is the equation that is on the equation sheet. I'm not sure if it uses sine or cosine, but this is the way they express it on the equation sheet for the AP exam. So just be aware. Oh, one other thing, and this has been mentioned a couple of times just sporadically in some of the videos, but I don't think it's been really clear, cut, and dry. You need to make sure that you are in radian mode in your calculator when you are solving your position time equations. Okay, if you are in degree mode, you are not going to get the right answer, so make sure you're in radian mode. Okay, so forces, and this is another thing that's very, very challenging about this. We can draw free body diagrams for any point in the object's motion. Just like when we hung an object from a spring at its equilibrium state, we just drew force spring up and mg down, and we had them equal and opposite. What you have to be careful with when using forces is we can't use those to solve for velocity. So we can solve for instantaneous accelerations, but you got to remember the force spring versus stretch distance graph. The spring force is not constant. We're used to it being constant. So we can use this expression kx equals ma to solve for any instantaneous acceleration. So when the object's at the midpoint, the acceleration is going to be 0 because the spring is not stretched nor compressed. So your maximum accelerations are going to occur at the two amplitudes. One thing it does get a little bit tricky is, remember the equation for force spring is negative kx because that indicates a restoring force. So when the object is actually at its negative position, the force is positive, which means you're going to have positive acceleration. If you think about how the motion is occurring, it's kind of common sense with that. Okay, I already mentioned this a little bit with velocities, but we can find all the velocities, but we need to use our energy equations. Don't try to use kinematics anywhere on any of these mass spring oscillations because that's not going to work. Several of you on handout 811 last week tried to use some kinematic equations, and that just is not going to work for these because you have a non-constant acceleration. So we can utilize our energy equations. Most of the mass spring systems and oscillations are going to be on a level frictionless surface, which makes it really easy because all of the energy is conserved and it goes strictly from the spring to the kinetic energy of the object, back to the spring, back to the kinetic energy, and it's like watching tennis where it just goes back and forth. So, once again, the velocity is greatest at the midpoint. So remember, the acceleration is 0 at the midpoint, but the velocity is the greatest at the midpoint. Okay, so those things that we have to understand. Remember, we're still looking at position versus time graphs, folks. The slope is velocity, so you should be able to find the slope of the line. One of the videos went into this equation. The period equation is on the AP equation sheet. There is a pretty simple derivation on this. We usually do it in class, but we're not going to go through that with you. I felt like the Khan Academy video did a good enough job explaining this. But remember, the period of a mass spring oscillator does not depend on how far you pull it back. You can pull it back 1 centimeter, you can pull it back 10 centimeters, you can pull it back 20 centimeters. You let it go, and the period over and back is going to stay the same. The only thing that's going to change is the amplitude. So the only factors that affect the period of oscillation is the mass and the spring constant. And based on the equation, you should be able to figure out what happens. So let's walk through this one real quick and I will be done. I'm going to move myself up a little bit here. All right, so let's say we have an object that's pulled back to the negative x position and released. So if we pull this back, and you're going to have to understand just kind of how to sketch these because you are going to be asked to do this several times. If you pull this object back to the negative x position, that means we are starting at the maximum x negative amplitude. We release it at the midpoint is when it's moving the fastest, so there's the steepest slope. You will notice when we get over to the velocity graph that this point right here matches up with this maximum velocity at this point. Then the object gets all the way over here to its maximum position here and returns, and it's moving at its fastest while it's moving left right here at the midpoint. Since this is a negative cosine graph, then we know that the velocity graph is going to be a sine graph. Remember, I walked through those little steps up above. So the velocity graph, even though we're at a negative position, the object is initially going to be moving to the right, and it's going to be moving at the maximum velocity to the right here, and it begins to slow down. So remember, even though this is a negative slope, it's still positive velocity. And we should also know the slope of the velocity graph is the acceleration. Since the slope is the greatest at the midpoint, your acceleration is going to be the greatest. So you have a sine wave for the velocity graph and your cosine graph for the acceleration graph. Remember, I said when the object's over here at the leftward position, that's when it has maximum positive acceleration. So notice the x position graph is negative. The acceleration graph is maximum positive at that. So the position and the acceleration graphs are always just opposite from one another. All right, so Mr. McDonald's going to go through a massive practice problem with you guys. You will be taking some notes over that and then in submitting it. We will give you guys your first round of the handout. We've got a couple of these rounds coming at you guys for the rest of the week. So you're pretty much, other than a couple of really short topics, you're pretty much done with all of the note taking in the videos this week. Okay?